All right, the reason I had you guys do the system of equation for homework is that we are going to use matrix to solve system of equation. But we're going to do that with, so basically solving system of equation, you have done that in chapter 3 for, 2 equations and 3 equations, and then you practice that for a while. Now we can actually solve that with matrices. So basically now you're going to have 3 ways. One is this way. The second way is the inverse matrix, which we're going to learn today. And then the third way is the row operation, which we're going to do 2 days because it is pretty tricky. There is a very specific order that you have to follow, and it's kind of like a game. So then if you're not good at the game, it gets very long. Okay, inverse matrix. So how do we use inverse matrix to solve the problem? We have to use the fact that A times A inverse is equal to I. That's going to help us solve the problem. So the matrix times its inverse is going to give us the identity matrix, and that's going to help us solve the problem. So for example, let's look at this one. Matrix times X matrix is equal to matrix. So what does your intuition tell you? How will I find X? Well, if this were a very simple problem, let's say 2x is equal to 10, what would you do? Divide, right? You would divide. However, in the matrix world, there is no division in matrices, so we cannot divide, or else we would have divided by that matrix. So we had to do something that is similar to dividing in the matrix world, which is inverse matrix. So for example, so I'm going to rewrite this problem here. I'm going to write it this way because there's a reason I need to leave a big space. So to get rid of that matrix that's next to X so that I can find X, I need to use the fact that matrix times inverse matrix is going to give me I matrix. So what I'm going to do is I am going to multiply by the inverse matrix. I am going to multiply by the inverse matrix. That way it will give me the I matrix. And I matrix, remember from the identity you learned a few sections ago, identity matrix times any matrix is that matrix back. Because identity matrix is like 1. So 5 times 1 is 5. So basically, the identity matrix does nothing to the whole problem, which is what we want. Okay, so again, the reason we are multiplying by the inverse is so that we can get a I meaning like a 1. So basically, think of it like this. This question is like 2x equals 10. And in order to get rid of the 2, I usually divide by 2, right? We always divide by 2. But to solve this problem, they're basically saying multiply by 1/2, the reciprocal, which is the same idea as the inverse matrix. Okay, good. So then that way, if I do it on the left and the right, x is equal to 5. So then I can find x. Okay, so same thing here. Now, in the matrix world, it's a little bit tricky, which we proved last week. Is AB equal to BA? No. So what does that mean? AB is not equal to BA. So what do we have to be careful on? Order. The order matters. Therefore, when you multiply the inverse matrix, you have to care about which order you multiply. It has to be the same direction. Okay? Yeah. Yeah, you will get a totally different number. And sometimes you can't even multiply. So please make sure that you look at the order. To get rid of the matrix on the left, you multiply by the inverse matrix on its left. Therefore, on the right-hand side, you have to multiply by the inverse matrix on the left of the matrix. Okay? So sometimes they'll give you problems where they will trick you. They put this matrix that you want to get rid of on the right-hand side. Then on this right-hand side matrix, you have to put it on the right-hand side. Okay? So order matters. The order you multiply matters. Okay, so this is going to give us, okay, so caution, AB is not equal to BA. Okay, so this means that the X matrix is equal to whatever it is that we end up multiplying. All right, so first, to solve this problem, we have to figure out this inverse matrix. So you did that for homework, which I also did it here. So we had to find the inverse matrix, which is 1 over determinant. Determinant, so we're going to do the reverse breast cancer awareness sign. So 5 times 2 is 10, minus 3 times 3, so that's a 1. That's a nice one. And then we need to switch A and D, and then make BC negative. Okay, at this time, sometimes there's going to be not nice determinant numbers. I would multiply the scalar last. So I would multiply these two matrices together and then multiply by the scalar last. That way you don't have a lot of fractions if it's going to make a bunch of fractions. Okay, so now just multiply. All right. 1 times 2 plus negative 3 times 3. That is 11. Okay, and then 1 times negative 3 plus negative 3 times 5. That's negative 18. Okay, so this is the answer. So that's the X matrix. Good? Okay, so this one you do need to remember everything that you have learned up to this point in order to solve it. So please make sure you kind of review your notes. Practice. Okay, this matrix. In order to solve X, do we multiply the inverse matrix on the left or on the right? Left. You guys are all okay? On the left, so the matrix, inverse matrix goes on the left. No, Kayla. Okay, so in order to get rid of this matrix, we have to multiply by an inverse matrix. Now the inverse matrix cannot go in between these two matrices, so it has to be like really close to this matrix to get rid of it, which is on the left. The only open space is on the left. Okay, so then we have to make sure we multiply on the left. How about this one, B? Multiply on the left or on the right? Left. This one is also still on the left. I don't think I gave you one that's on the right. Okay, so let's just have you guys try it. So go ahead and find the answer to this one, A, and then let me know when you're done. All right, in order to solve this problem, we need to multiply by the inverse matrix, but inverse matrix goes on the left. We did that. Okay, so I think by this time, everyone knows that. However, we didn't find, or a lot of you did not find the inverse matrix before you solved it. You just found the determinant and you said that's done. No, you got to find the inverse matrix. Okay, so the inverse matrix of this one is 1 over determinant. Determinant is 4 times 2 minus 2 times 3, so that is 2. And then some of you did that, and then you just went like this, and then you said done. Okay, that is not what we're doing. We are looking for the inverse matrix. We're not done with the inverse matrix. Switch A and D, make BC negative. Okay, and then take that and multiply by that matrix. Okay, you gotta do that inverse matrix the whole way through. At this time, you can see that if I multiply the scalar in, I'm gonna get a whole number, whole number, whole number, fraction. So if you're okay with dealing with just one fraction, then do multiply in. If you don't like even one fraction, then don't multiply. Multiply these two matrices together first, and then multiply by 1/2. Because the scalar order doesn't matter. Okay, so 1/2, and then we're gonna just leave that on the side. Okay, I'm gonna multiply this. Okay, this is where, please don't make mistakes. Okay, so negative 5 times 2 is negative 10, plus 2 times negative 3, that's negative 16. Okay, and then the second one, negative 5 times negative 2 is 10, plus 2 times 4, that's 18. Okay, at this point, take that 1/2 and then multiply it. So, negative 8, 9. Yeah?
How did you get positive 18?
Negative 5 times negative 2 is positive 10. 2 times 4 is positive 8. Okay, let's have you try one more. Okay, B, let me know when you're done. Okay, so the X matrix is negative 14, negative 20, 19, 28. Okay, so this is all good and stuff, but we are really going to use this to actually solve problems. This is just kind of practice of how to do it, but we need to use it to actually solve problems. Okay, so let's go to the next page. We're going to use matrices to actually solve these problems. Now, we have to make sure that all our equations are in this form, which is in the standard form. Ax plus by equals c. So this is the standard form of a linear equation. Okay, all our matrices have to be in this, equations have to be in this form in order to use matrix. So if they're not, we have to change it. Okay, so for example, this one, are both of them in standard form? No, so we have to change them. The first one is in standard form, the second one is not, but the second one is not too bad. We can just switch it a little bit. So this is the first equation again. The second equation is 5x minus 2y equals 13. So they have to both be in the standard form. Now what we're going to do is we are going to rewrite this as matrices. So the coefficients go together as one matrix. So it goes 2, 3, 5, negative 2. Like that. Okay, so the coefficients, take all the numbers, coefficients, put them into one matrix. The next matrix is the... Huh? No, I just swapped it. Take this whole thing and yeah. Okay, and then the next thing we have is the XY matrix or the variable matrix, and that's equal to the constant matrix. Okay, so this is the coefficient matrix. This is the variable matrix, and this is the constant matrix. So this is how you set up a system of equation into matrix form in the inverse matrix way. Tomorrow we're going to learn a different way. Okay, so let's just practice setting this up before we actually solve it. So let's have you try this next one. I just want you to set up the matrix. So how would you set up the matrices so that you can solve? So you have a coefficient matrix, variable matrix equals constant matrix. So go ahead and set that up, and then I will check it. All right, so this one becomes 4, 7, minus 5, 3, xy equals 6, 1. Now, if you didn't set it up that way and then you had all the negatives differently from mine, which is okay, because remember that you could also have it, I don't know, 4, 7, let's say you do 5, negative 3, which is okay, but on the other side, you're not going to have a 6, 1, you're going to have a 6, negative 1, and that's okay, because you just moved it differently. The negative doesn't matter. Okay, now that you know how to set it up, we are going to solve, and I think you should be able to solve it, right? No. Okay. All right. What's the setup on this matrix? okay? And then times xy is equal to 4, 3, right? How do we solve this? By inverse matrix. What do we have to multiply by to get rid of whatever is next? Yeah, the inverse of this one. So then we are going to multiply by 5, -4, 3, -2, inverse. And we're going to do the same thing here on the left. It's a little small. 5, -4, 3, -2, inverse. Okay, that's going to leave us with just the xy matrix. 5, -4, 3, -2, inverse times 4, 3. Yes? Okay, solve that one, and then I'll tell you what the results mean. Okay, once you solve it, you should get 2, 1.5. Well, what does that mean? It means xy. So the first number on the top means x, the second number means y. Okay? Yeah.
How do you get 2 and 1.5?
What number did you get?
I got 4
And 3?
and 27.
You might have to check it with someone next to you. It's just the way you added, or I think you may have forgotten to multiply by your determinant as well.
Oh, yeah, I forgot.
Okay. Okay, let's try another one. Okay, let me know when you're done. Okay, the answer is x is equal to -1, y is equal to 0. All right, we're gonna try one last one. Okay, now this is not in the right form. You're gonna change it to the right form, and the numbers are a little big. And for the tests and things like that, it's not gonna be this easy. I'm gonna give you word problems. You're gonna have to set up the equations so that you can solve it with matrices. You know how to solve word problems. We did word problems for a whole chapter, so yeah, you can do it. But we're gonna do this with warm-ups, so then it's not gonna be the first time you see word problems on the test. So we'll do word problems for the next 2 days. Okay? All right, try this one. All right. The answer is 12.5 and 1187.5. If you didn't get that, let me know later. And I can help you figure out what you did wrong.